Well, Assalamu alaikum dear students. I am engineer Abdul Basit and this subject is actually hydraulics. Okay, we are in week number 5, lecture 2. So basically this is the second lecture of this week 5. Okay, the topic we are going to discuss today is measurements of fluid pressure. Okay, so how we can determine the fluid pressure in a pipe, or you can say in a closed channel. uh, in previous tutorial of the same week we have discussed about the different types of fluid pressures, that is basically the gauge pressure, the atmospheric pressure, that vacuum negative pressure, or you can say and then positive pressure, that differential pressure. So all the types are being discussed in the previous tutorial. Today we are going to discuss about the measurements of fluid pressure. Okay, so how we can measure that fluid pressure in a channel, or in a closed channel, in a pipe. Okay, there are different devices used for the purpose. Okay, first of all we have that piezometer, and then we have manometer. So in manometer we have 4 different types of manometers that are used for the same purpose. Okay, uh, what phenomena do these devices used to determine the pressure in a pipe is the balancing of the liquid columns. Okay, so as these devices will determine the gauge pressure in a pipe. Okay, so you can say that it will use a phenomena that two pipes of same liquid or of different liquid will be balanced due to the same pressure in the pipes. Okay, and that phenomena will be used to determine the gauge pressure in the pipe. Okay, so how we can do it? For example, coming to the piezometer, first of all, this is a very simple devices that is used to determine the fluid pressures in pipe. uh, why it is so simple, and how we can determine the fluid pressure, and what are the precautions that we should keep in mind while using a piezometer. Here it is, the whole phenomena. First of all, for example, you are having a pipe like this. Okay, and this pipe is filled with water, or water is flowing through it, or any other fluid is flowing through it. Okay, what simply you can do is to connect an shape pipe to it at a 90 degree, or you can say at a right angle to the pipe. Okay, so as you can see this in the figure, this is an L-shaped tube, which is an empty tube that is made up of transparent glass, and the tube is graduated as well. Okay, uh, let me change the setting first of all. So here it is. Okay, so then you will see that these graduations are provided in the form of you can say in millimeter or in centimeter units. Okay, uh, mm, that what phenomena do this piezometer use is the level of the pipe of the water, or the fluid that is flowing in this pipe, will rise in this tube. Okay, this is, as I mentioned, that this is a transparent glass, also graduated, and the top end of the tube is open to the atmosphere. So if it is open to the atmosphere, so the first thing is like atmospheric pressure is acting on it. Okay, so this water that is flowing in the pipe will rise, or you can say will enter into this pipe and will rise in this tube. Okay, and as this water will rise against the atmospheric pressure, so you can say it will take that reference line of atmospheric pressure. So if we are using reference line as atmospheric pressure, so it is gauge pressure determination method. Okay, as I mentioned in the previous tutorial. So that is the one concept that we should keep in mind. Secondly, when the water is flowing through this pipe and it is entering this tube, and will rise, the water level will rise here in this tube. Okay, so you will see that the water is rising over here. Okay, how much the water is rising, okay, that will be determined by these graduations. Okay, so you will see, for example, 10 centimeter or 5 centimeter of the water level is raised here in this tube. So this 10 is actually the head of the water that is flowing over here. So once we determine the head, we can easily determine that pressure as well. Okay, how we will do it? Simple. The phenomena is, or you can say the formula for that is that that pressure is equal to omega h. Okay, is equal to omega h. So this h is actually this head. Okay, that is the level raised in the of the water or any fluid in this tube. Okay, and this omega is actually the unit weight. Okay, so once you determine this h, so this unit weight is quite simple, the unit weight of this fluid. Okay, for example, it is water, so this unit weight will be equal to 9.81 kilonewton per meter cube. Okay, so if this is some other liquid, so the specific gravity or unit weight of that liquid will also be mentioned, and you need to determine this h only with the help of this device, and the other term, that is omega, will be given to you. Okay, or you can simply determine it from the manual given with the water. Okay, with the fluid. So this is how you can determine the pressure in this pipe. So this pressure will be actually in the head of water. Okay, as this is, for example, water, and the unit weight of water is multiplied over here, so whatever that is determined by this h will be in the centimeter of water or in head of water. Okay, so what does it mean by head of water? I have already explained it in previous tutorial. Okay, uh, the precautions you should keep in mind is that the connection of this piezometer with the tube should be at right angle. Okay, number one, this should be a 90-degree. Sorry for this bad drawing, this is 90-degree. Okay, this will be 90-degree. And secondly, this pipe shouldn't be projected inside the pipe. Okay, so that it will increase the pressure in the pipe, the friction in the pipe, and will create some turbulence in the pipe, so the level rise over here will not be that accurate pressure of the water inside this pipe. Okay, and the third thing is this connection should be a smooth one. Okay, should be a fillet connection over here, not that angle connection, not this type of connection. This should be a smooth connection like this. Okay, so that the friction between these two pipes, or the water entering in this pipe, should be minimized. Okay, so these are the precautions that should be kept in mind. Okay, these three precautions. Okay, that is how you can use piezometer. So I think this is quite simple, no need for further explanation to it. Okay, but the drawback of using this device is that it is unable to determine the high pressures, as when the pressure in this tube is so high. Okay, so then the water will rise over here, okay, in this tube, and will overflow from here, okay, as this is open. Okay, so high pressures cannot be accurately determined with the help of this piezometer. Secondly, negative pressure cannot be determined over here. So as negative pressure mean that the level of this water that is raised over here in the piezometer should be in the negative direction. Okay, so as you can see that there is no negative direction available for us, there is no pipe over here. Okay, so if this is no pipe over here, so then no negative pressure can be determined with the help of this device. Okay, as negative pressure actually refers to the vacuum that is produced over here. Okay, so if vacuum is produced, you can say that that pressure cannot be determined with the help of piezometer. So there are two drawbacks: no high pressure can be determined over here, and no negative pressure can be determined with the help of piezometer. Then coming towards manometer, so this is that modified form of that piezometer. Okay, first of all, this is quite suitable for determination of high pressures, and secondly, it can determine the negative pressure for us as well. Okay, so as I told you that this is improved form of the piezometer. Okay, so there are four different types of manometers. One that is simple manometer, then micro manometer, and then differential manometer, and inverted manometer. Okay, So in coming few tutorials we will discuss about these four in detail. Okay, now let's discuss this simple manometer first of all. Here it is that shape of the simple manometer. It is unlike that piezometer which is of L shape. Okay, this manometer is of U shape. Okay, U shaped. Okay, and here it is shown, and then you can see that piezometer was empty. Okay, an empty transparent graduated tube. Okay, but manometer is not empty, it is filled with a heavier material. Okay, that is mercury, for example. Mostly we use mercury over here. Okay, Ag, sorry. Okay, mercury over here, and that is having a specific gravity of 13.4. Okay, 13.6 if I'm not wrong. Okay, so if this is a heavy material, so when the pressure is exerted by this pipe, or the water or any fluid present in this pipe will create a downward force over here on the mercury. Okay, so if the mercury is pushed over here, so what will happen, this mercury level will be decreased in this lamp and will increase in this lamp. Okay, so if this is increasing over here, that level should be determined, and if it is increasing more, so you mean it mean that pressure is comparatively greater. Okay, if this level is decreasing, so this is negative pressure, as you can see here, that the level of the mercury is decreasing. So you can say that vacuum is created here, and there is a sucking phenomena over here, that that this mercury is exerted by some sucking force. Okay, in this lamp. So if the level of the mercury is rising over here and is decreasing over here in this lamp, so then this is a negative pressure. In other words, simply you can say that how we can, this was a simple phenomena. Now practically how we can use it, the practical thing is, first of all, let me remove this all. First of all, you have to divide this whole piezometer manometer in two parts. Okay, one is the left lamp, this one, and this one is the right lamp. Okay, so when there will be a positive pressure, when the level of mercury in the left lamp is decreasing and level of the mercury in the right lamp is increasing, so this will be a positive pressure. If the level of the mercury in the left limb is increasing and a level of the mercury in the right limb is decreasing, this will be a negative pressure. This is their basic definition. Then how we can use this whole thing for the pressure determination. So first of all, there will be some fluid over here in this pipe which may have a specific gravity. Okay, let us denote that with S1. Okay, this mercury is also having specific gravity, that is S2. Okay, so as this is mercury, so you can say Sm can also be mentioned over here, and that is 13.6. okay, 13.6. so this is known, and this may be known, may not be known to you. Okay, secondly, there will be some pressure of this fluid. Okay, that can be determined in the form of head. Okay, which we need to determine. This should be determined. Okay, this is our task for this manometer. And then whenever the pressure is exerted by this fluid on this lamp, on this left lamp, what will happen, the level of the mercury will decrease. Okay, so how much it is decreasing and how much water is entering in this left lamp, the height of that that water or that fluid is actually determined by H1. Okay, so that is with respect to the level of the mercury and center of this pipe. Okay, so this is H1. Okay, secondly, this level of the mercury is actually Z over here. Okay, that should be passed through both of the lamp. Okay, and then the level of the mercury in the right lamp is increasing. So if it is increasing, so there is some pressure over here as well. Okay, so what will be the equation? In the left side we will have two pressures. Number one, this H, okay, and secondly we will have a pressure in this limb, this part, okay, that is H1 into S1, as this is the same fluid which is present in this pipe, okay, and this is having a specific gravity S1, okay. So H1 S1, this is the pressure in the left limb, okay. In the right limb the pressure will be like H2, as the level of the mercury is H2, and there is only one liquid over here, that is this mercury, okay. So you can say that will be H2 S2. So this is their situation in the right side, okay. So as when the water is flowing over here, initially the level of the mercury will get decreasing over here and increasing over here in this limb, okay. But a time will reach that these two ends will be balanced, okay. No increase over here and no decrease over here will be seen, or you can say no change in the level in the both limbs will be seen. So you can say this is an equilibrium condition for us, where the pressure in the left limb and the right limb is balanced, okay. So if both the pressures are balanced, so you can say this one and this one will become equal, okay. Then the equation will be like, here you can see that in the left limb we are having H, okay, and then we have H1 S1, okay. This will be the situation in the left, and this will become equal to the pressure in the right limb, which is H2 S2, okay. This is this H2 S2 and H1 S1, this is the same thing, that is pressure is equal to omega H, okay. But here this omega unit weight is replaced with the specific gravity, okay. Why it is so, this will be explained later in the examples, okay. So this is the situation for us. Now what we are going to determine is this H, okay. The rest of the things are given. H1 is given, that is the pressure in the height of the water in this limb, left limb, and S1 is the specific gravity of this fluid, okay. And this H2 is given, that is the height of the mercury with respect to the Z in the right limb, okay. And this S2 is again that same thing, okay. So that is there, that's a simple manometer, okay. Here you can see this will be that equation which will be developed for you. So all the things are known for us, and this H needs to be determined, okay. So taking all the remaining terms to the right side, okay, this will be that equation for us, which will be in meter of water, okay. That will give us a head in the meter of water. If you want to find out the pressure from here, so this will be P into omega H, okay. So this H is determined, multiplied to the unit weight, and this will be the same thing. So here you can see that this is in meter of water. If it is in meter of water, why it is in meter of water? Because we are using this specific gravity over here, okay. As the specific gravity is actually equal to the unit weight of that particular fluid that is flowing in the pipe, which may be an oil, maybe water, with respect to the unit weight of water. This is the thing, okay. So if it is with respect to water, so that will give you in meter of water that pressure. If it is with respect to some oil, okay, you can say petrol, P, okay, omega divided by omega of water, so this will be in meter of water. If it is omega of petrol, then it will be in meter of petrol, not water over here, okay. So this is that modified form. You can say that you can utilize it for other way in meter of water, meter of petrol, meter of oil, whatever terminology you want to use, okay. So here it is that thing. If you are facing some different situation, that is in the case of negative pressure, so what will happen? This will be in the negative pressure. Let me remove this thing for you. Here it is. For example, negative pressure, what will be the situation? This is that these two limbs divided into left limb and right limb, okay. In the left limb we are having this pressure, which is the pressure in pipe, H1 H, plus we are having this H1, small h1, okay, this is H1 into S1. This is situation in left limb. And similarly above H we are having mercury as well, okay, and that mercury is H2 height. So similarly this is also in the left limb, so this will be H2 into S2, okay, S2. And in the right limb you can see there is no pressure above Z, okay, so you can say this will be equal to 0. Now from this equation you can determine this H for yourself, okay, and that will be how you can do it. Whole equation will be like this, okay, and this will be the modified form, or you can say rearranged form, and this H can be determined from this equation, and which is like this. And again this will be in meter of water, as we are using specific gravity, okay. So now coming to that simple example on this, okay, how we can determine that uh, pressure in this fluid, okay, using this numerical. Here it is. For example, we are having a simple manometer containing mercury, okay, so you can say the other dense fluid is mercury, is used to measure the pressure of water flowing in a pipeline, okay. This is a pipeline in which the water is flowing. The mercury level in the open tube is 60 millimeter, okay, so this is that open tube, this one is open tube, okay, so this is the level of mercury in the open tube is 60, so this is in millimeters. And then higher than that on the left limb, okay, so you can say left limb situation is this one, and this is at Z, okay, and in the right limb the mercury level is raised by 60 millimeter with respect to this mercury level in the left limb. So if the height of water in the left tube is 50 millimeter, okay, here you can see height of water is 50 millimeter, determine the pressure in the pipe in terms of head of water. So here it is mentioned in terms of head of water. So what will you use? The specific gravity phenomena, okay. So first of all you have to see this whether it is a positive pressure or negative pressure. So I think from the previous few slides you have you will understand specifically what does it mean when the level of the mercury is raised in the right limb with respect to the left limb. This is a negative pressure, okay, already I have discussed in previous slides, okay. Sorry, this is positive pressure. I'm really sorry, this is positive pressure. So now you can see that we will use this equation for that, okay. This is the situation in the left limb, H plus S1 H1, okay. So here S1 is, as this is water, okay, here, so if it is water, so S1 for specific gravity of water is 1, okay, and H1 is 50, and this is the situation in the left limb. So this is equation number 1 for you. In the right limb we are having pressure due to this mercury over here as well, only, okay. So here it is 13.6 multiplied by 60, and this is mercury, so S2 will be used over here. 13.6 is the specific gravity of mercury. Again this will be in millimeter of water, okay. Now equating both the equation 1 and 2, as the pressure in both the limbs is equal, so you can say this will be equal to this thing, okay. You can say equation 1 will be equal to equation 2, these two equations. So from these two equations now you can determine H for yourself. Here it is, okay. So this will be equal to 766 millimeter of water. Now coming towards that thing, for example, a sample manometer is, this is that second example for you, that is 2.6. A simple manometer is used to measure the pressure of oil of specific gravity 0.8, okay. So specific gravity of the oil is given. Now there is no water over here, here it is oil now, okay, and its limb is open to the atmosphere. It's right limb, so right limb is open to atmosphere, so definitely it will determine the gauge pressure for you now. And the left limb is connected to the pipe. Okay, so this is that simple situation. The center of the pipe is 90 millimeter below the level of the mercury. So here it is, the center of the pipe, this is center of the pipe, okay, which is below the level of the mercury. Okay, level of mercury here, level of the mercury in right limb, here it is written. Okay, so level of the mercury in right limb is over here. This center of the pipe is 90 millimeter below the level of the mercury, so here it is. Okay, and secondly, the situation is, here it is, if the difference of the mercury level in the two limbs is 150 millimeter, so the difference of the levels in the two limbs, difference of the level of mercury, so this is mercury level in the left limb, this is mercury level in the right limb, the difference between these two is 150 millimeters. Okay, so from this you can determine this H1 for yourself now. Okay, how you can do it, 150 minus 90 will be equal to H1. Okay, so H1 is equal to 150, this is a simple geometric calculation, 150 minus 90. Okay, so this is equal to almost 60 millimeters. Okay, so then if H1 is given to you, this is a a fluid which is having a specific gravity not equal to 1. This is having a specific gravity 0.8. Okay, so here it is, this is sorry, this is having a specific gravity 0.8. Now this is somehow complicated than the other one. First of all, you need to determine this H1, which is determined over here. Then left limb and right limb should be equated. So here it is, in the left limb we are having this H1, which is needed to be determined. Already I have done it in the previous slide. Then this is their situation in the left limb, as this is a positive pressure. You can see it from here that the level of the mercury in the left limb is decreased, and the level of the mercury in the right limb is a bit higher than with respect to the left limb. So this is a positive pressure situation. So you will use this equation where H plus S1 H1 is the pressure in the in the left limb, and this one is the pressure in the that right limb. So here it is, S1 in this situation will be equal to 0.8, and 60 is the height. Okay, so here this will be that equation 1 for you. Okay, and this is that equation 2 for you, where mercury is present and specific gravity of mercury is 13.6 for you, and H2 is actually equal to, this is H2, the mercury level difference between the two limbs is 150, which is H2. This is H2. Okay, so if both the things are given, you have to use it, and now equate both the equations, as this is a balanced pressure situation. So both in the right limb and left limb the pressure will be the same. So here it is. Okay, this is now H for you, that is the pressure of the fluid in the pipe. Okay, now this is pressure head. If you want to find out pressure, so already I have mentioned that in previous slide, that P is equal to omega H. Now this omega is actually the unit weight of water. Okay, as the head is in meter of water. Okay, so you have to use the unit weight of water over here. Okay, as if if this head is in the meter of something else, then you should use the unit weight of that particular material over here. Okay, so now this is, in this pipe we are having oil, but still we are using water over here. Why? Because the determination of head is done in the meter of water. Okay, so this is 9.81, and this is that head for you, and here it will be in kilopascal, the pressure of the pipe of the fluid in this pipe. Okay, then also H may also be obtained directly by the relation. So this is that direct relationship where you can use the that equation by that simple or direct method, where H is equal to S2 H2 minus S1 H1, which is this equation for you. Here it is. Simple. You can use this equation as well. Okay. But that detailed method is quite accurate and easy to perform, and conceptually it will be easy to understand as well. Okay, that's all from this lecture. Inshallah, in the coming slides and coming tutorial, inshallah, after midterm we will discuss about few more examples from the same thing, from the same topic, and then we will go towards the gauge pressures. Okay, thank you very much.